What about the number 12? Okay, what about the number 12? There's multiple ways to write the number 12. You can write it as the number 12. You can also write it as 2 times 6, because we know that's equal to 12. You can also write it as 3 times 4. We know that that's equal to 12. We also can write it as 1 times 12, because that's equal to 12 as well. So if I ask you, all right, take 12 and factor out a 3, what do you think that's going to mean? Well, the word factor, I just told you 4 times, it means pull out. So what I'm telling you to do is pull out a 3, all right? I'm telling you to pull out a 3. So if I pull out a 3 from 12, I have to write my 3 down and I'll write my parentheses. What's going to be left over if I pull out that 3? If I reach inside of this number 12 and pull out a 3, then the only thing that can be left is 4 in here. Why? Because 3 times 4 is 12. So when I say pull it out, I don't just mean magically pull it out. I mean go and remove it and then make the expression still equal 12 in the end. So when you pull it out, you're pulling it outside the parentheses, and whatever's left inside, you have to make it such that whenever you multiply everything together, you get 12 back to begin with, which is kind of like the simple example I'm giving you here. If I tell you to, instead of this, if I tell you to factor out a 2 from 12, then what do? Here's your 12, you want to factor out a 2. Well, you have to pull the 2 out. What's going to be left inside? It has to be 6, because the whole expression, we're basically saying these are equal. We're saying this is equal to 12. When I reach into 12 and I pull out a 2, what's left has to still multiply together to give me 12. That's why I wrote these down to remind you of what 12 can be multiplied together. So these are called the factors of 12. The 2 and the 6, they're factors of 12. The 3 and the 4, they're factors of 12. So when you pull out a 2, you have to have a 6 left over to make it equal to 12 after you multiply. When you pull out a 3, you have to have a 4 left over, so that when you do your multiplication, you'll still have 12. So that's all in terms of numbers, right? And you can do these examples with any number you want, but we need to eventually start working in terms of algebra. So let me erase the board and I'll show you how to factor a simple algebra expression. All right, what if my expression to you is 3x plus 6? And I'm asking you to factor this expression. And by the way, when I say factor, I'm trying to find the greatest common factor between both of these things. Basically, what I'm going to try to do is look at both of these terms and figure out what's really common between these two terms, and then pull that number out. And it's a way to kind of reverse simplify the expression, basically. You're trying to create a new expression that's the same as the original one. You're not changing anything. You're just changing the way it looks. And so you want to look at commonality. So there's an x here, but there's no x there. So there's no way, no how that I could pull x out of this expression. There's no way, because it's not common to both things. You might say there's a 3 here and there's a 6 here, so there's nothing in common. However, 6 is really 3 times 2. So in fact, even though it doesn't look like there's anything common, I actually can pull a 3 out of this expression. So you open up a parenthesis, and you have to write down in the middle what would be left over to make it equal to what you started with. You'd have to have x plus 2. Now let me show you why that's true. Because if you cover this up, and I tell you, hey, here's 3 times x plus 2, distribute this in. We've learned about distribution so much, you should know that it's going to be 3 times x plus this, which is going to be 6. 3 times 2 is 6. So 3x plus 6. That's exactly what we have, 3x plus 6. So when you factor an expression, you're looking between your terms, you're trying to find out what's common, and you're trying to reach in there and pull everything common out. And then whatever's left over inside the parentheses has to make sense, so that when you do the reverse multiplication again, if you do it, check it, you're going to get back what you started with. So you have to reach in, pull it out, and this has to make sense so that when you do the multiplication, you get what you started with. That is factoring, right? So let's do a million problems here to make sure you understand, but that is the basic concept. What if I have an expression, x times y minus x times z? So what I'm doing is I'm looking, there's no numbers here, so it looks hard, but then you realize I'm looking here for things that are common. What's common here? I have an x here and I have an x here. That's the only thing common. I have no numbers, and I have no other letters that are common. Since x is common, I pull it out and I open my parentheses. Whatever I write in here has to make sense so that after I do the distribution, it equals this. So once I pull it out of the first guy, the only thing left over is y, And once I pull it out of the second guy, the only thing left over is negative z. So this is my factorization, and if you want to check it, you just distribute this, x times y minus x times z, and that's exactly what we started with. So it takes a little bit of practice at first, but quickly you will get the hang of it. What if we had something like t cubed plus 2 times t squared? And I wanted to factor that. Now again, the name of the section is factoring the greatest common factor. It means you're looking at your terms, you're finding out what's common, but really you want to pull out the largest thing you can that is also common to both terms. So you look at this and you say, well, all I have is a t cubed, and here I have a t squared. So you look and you say, well, those don't match. But then you realize that this is really t times t times t. And this guy is 2 times t times t. So even though it may not look like it really when you look at this guy and this guy, you have 2 t's common to both of these terms. 2 t's are common. T squared is common here. I also could factor out a t squared from there. So I'm going to factor out my t squared. I'm going to open my parentheses. What do I need to write down here to make it true? I need to write down t here plus 2. This is my factorization. And if you want to check it, just cover everything back up and distribute it in. T squared times t gives me t cubed. T squared times 2 gives me 2t. So you're reaching in, you're looking to see the largest common thing here. In this case, t squared is common here, and it's also wrapped up inside here. I can pull it out, and then I go and figure out what needs to be in there to make the multiplication true. And ladies and gentlemen, this is really the only thing to this section. There's not anything else to it. We're just going to work some problems. So r to the 4th minus r squared. What would you factor out here? Well, we can see that there's an r here, common in both terms, but how many r's? Here we have 2 r's. Here I have 4 r's. So I know that I have at least 2 r's common here, and I have 2 r's that are also common to that guy. So I can pull out an r squared. I can pull out 2 of them. So for the first term, I'd have to have an r squared in the middle to make 4. And here it would just be minus 1 because I pulled out all of the r squares on the outside. So the only thing I have left is a 1 there. Now to check it, r squared times r squared is r to the 4th. R squared times negative 1 is negative r squared. So that's the answer. Now let's do a slightly larger one. Let's say I have 12 times r squared minus 3 times rs plus 9 times r squared s squared. All right, so I have 3 terms, and I'm trying to go figure out what is going to be common to all of them. You see, see in this case I have 3 terms I'm looking at. Whenever I try to factor something out, it has to be common to all of them if I'm going to factor out from all of them. So you need to make sure whatever it is common to everybody if you're going to try to pull it out. So I look at this and I say, here's a 12, here's a 3, here's a 9. All right, those are different numbers. But then I realize that there's a 3 kind of wrapped up in here because 3 times 4 is 12. There's a 3 wrapped up in here because 3 times 3 is 9. So I know for sure that 3 is common to all of these things. So I'm going to write a 3 outside. And then I look at my letters. I have an r squared, r, and another r squared. Clearly, r squared is not common to all of them because I don't have an r squared here. S is not common to all of them because I don't have any s's at all here. But r, just a single r, is common here because I have an r of 2 of them really. So I have at least 1 r wrapped up here, I have at least 1 r wrapped up here, and I have at least 1 r wrapped up here. So I can see that I could pull out a single r. I can't pull out more than that because I don't have enough of them here. So I can only pull out 3r. So I open my parentheses and I try to figure out what I need to write here to make this true. So I'm going to have to write 4r here. So that would make 12 times r squared. Over here, it's going to be negative. I already have my r, I already have my 3. The only thing left is s. So if you multiply, 3r times this is going to give me this. And then over here, 3 times 3 is 9, so I'm going to have 3. I already pulled out 1r, so I have 1r left, and I haven't touched the s squared, so they stay the same. So that is the answer, 3r, open parentheses, 4r minus s plus 3rs squared. And to check your answer, you can just back distribute. This times this gives me this. This times this gives me this. This times this gives me 9r squared s squared. So that's the answer. Now in this section, we're going to not only factor, but I want you to get practice with factoring -1 out of an expression. In the previous problems, we've pretty much just told you, hey, look for what's common and pull it out, right? But here, I want you to get practice with really factoring out a -1 because it's very useful and it's, you know, good practice for you, really. So how would we do it? Let me give the first problem. Let me give you a first expression. -a minus b. I want you to factor -1 out of there, right? So what you do is write -1 and you open your parentheses. You got to figure out what's going to go inside. This times what is going to give me -a. That's the only thing that works. This times what's going to give me -b. Positive b is the only thing that works. So when you back check it, -1 times a is this, -1 times b is this, so everything checks out. That is the factorization when you pull out -1. All right, now what if you have as another expression, -2x plus 5y, and again, I'm telling you ahead of time, I want you to factor out a -1. You write a -1, you open parentheses. So what happens? You look in here, -1 times what is going to give me this? It has to be a positive 2x. -1 times what is going to give me this? It has to be a -5y. It has to be negative because negative times negative gives me positive. So you back check it. This times this gives you this. This times this gives you this. I guess I'm really doing this to also show you that when you factor out a -1 from an expression, all that really happens is the sign of everything you started with just gets flipped. See, this was negative, it became positive. This was positive, it became negative. This was negative, it became positive. This was negative, it became positive. And let me show you one more to prove to you that this pattern holds. What if I tell you -3xy plus 2z plus 5w, and I want you to factor out a -1. So you just write -1 here, and what do? To make this correct, what would you have to write here to make this correct? It would have to be positive 3xy. What about this guy? You have 2z, so you have to have -2z here because negative times negative is going to give you positive. And over here you'd have to have a -5w, like this. And so this times this gives me -3xy. This times this gives me positive 2z. This times this gives me positive 5w. Notice again, this went from negative to positive. This went from positive to negative. This went from positive to negative. So the bottom line is when you factor out a -1 from an expression, all that happens is all of the terms flip their signs. That's basically all that happens. So let me erase the board and we'll get some more practice with factoring these guys. All right, so now we're going to flip back to just taking regular old expressions, -3x squared y minus 6xy squared, and now we're just going to factor them. We're not factoring -1 out or anything. I'm just asking you to look in here, find the greatest common factor, and pull it out. So we see that I have a 3 and a 6, so what's common between these two? Well, the only thing I can pull out is a 3, because it's common here and there's a 3 wrapped up here. And I'm going to go ahead and pull out a negative with it, so I'm going to have a -3 just because I want to get practice pulling out negative things. What about x? Well, I have an x squared here and only one x here, so I can only pull one x out because that's only one of them is common to both. Same thing with y. Only one y is common to both. So I can open my parentheses up and figure out what do I need to write in the inside. I've already got my -3. I've already got my y, so all I need is an x. So when I multiply these together, I'll retrieve my original term. Over here, I'm going to need a minus sign. I'm sorry, I'm going to need a plus sign. 3 times 2 is 6. X, it goes from here. Y, I've only pulled out one y, so I need to leave one y behind. So it's going to be -3xy times x plus 2y. You check your work by saying this times this gives me -3x squared y. This times this gives me -6xy squared. So really you're just reaching in, pulling things out, and you're kind of backwards assigning what you have in here to make it multiply properly. Okay, now let's say you have -4a squared b cubed plus 12a cubed b squared. And we want to pull out the greatest common factor. So I have a 4 here and a 12, but I know inside of this 12 is a 3 times 4, so I know that 4 is common to both. And just to get practice, I'm going to go ahead and pull out the -4. Because I can really pull out negative or positive, whatever, it doesn't matter, but I'm going to go ahead and pull out the greatest common factor. I'm going to say -4 because I have a negative here, and I can always flip the sign over here. Now, as far as the a's, I've got 2 of them here and 3 of them here. So I can pull out 2 a's, because at least 2 are common to both. And for the b's, I have 3 here and 2 here. So I know I can pull out only 2 b's. Now on the inside, the number is taken care of already because I pulled out -4. The a squared is taken care of. All I need is a b in the inside to multiply to give me this. And then for this, I need to multiply by 3. I need to multiply by 3 to give me 12. But it can't be positive because if I do this, 3 times -4 is going to give me -12. So this needs to be negative. So you need to adjust your signs on the inside to give you the sign of what you start with. A squared is what I pulled out. I have 1 more a inside. I pulled out both b's, so I'm done. That's the answer, -4, a squared, b squared, open paren, b minus 3a. So you check your work by multiplying this in. The b squared times the b is going to give me b cubed, so that's going to match. This times this, negative times negative, gives me positive. 4 times 3 is 12. A squared times a is a cubed, and then I have my b squared along for the ride, and then I'm basically done with this guy. All right, now I want to switch gears a little bit and show you how to solve some equations that kind of require factoring. So to build our way up there, I'm going to have something like x minus 2, x plus 3, and I'm going to set it equal to 0. And I want to talk about this. This is an equation because it has an equal sign, right? Equations have equal sign. We want to solve for x. Now we could do FOIL here, but then we're just going to have a large mess, and I'm not going to know how to isolate x by itself because I'm going to have, if I do FOIL, I'm going to have x squared, and then I'm going to have something times x, and then I'm going to have a bunch of stuff I can't isolate x easily. But anytime you have like something big like this multiplied by something big like this, and it's equal to 0, then you need to think about it for a second, and it's always true, so it's something you really should remember, is that this term, if I set it equal to 0, is going to satisfy the equation. Also, this term, if I set it equal to 0, is satisfy the equation. Let me show you what I mean, and then we'll talk about it. X minus 2 has to be 0. X plus 3 has to equal 0. When you have it like this, either one can be equal to 0. Why? Because if I say x minus 2 is equal to 0, if I put a big 0 in here, then it drives the whole thing to 0 and it satisfies the equation. If I say this is equal to 0, then if you put a 0 into here, it drives the whole thing to 0, and you have a 0 there. So no matter which one you do, you can set either one or both of them equal to 0, and you're going to satisfy your equation. Remember, when you solve equations, you only care about finding what values of x work to make it work. So this guy can be equal to 0. That's going to satisfy. This guy can be equal to 0. Now, it's almost like I started with one equation. Now I have 2 small equations. I can solve this by adding 2 to both sides. X is equal to 3 because I add 2 here. I should say x is equal to 2. I add 2 here, that makes it go away. I add 2 to the other side, and I get this. Over here, I subtract 3. Subtract 3 from the left, it disappears. From the right, it's equal to that. So this is the solution. I have 2 values of x that work. All of the equations up till now, you only had 1 value of x that work. Well, some equations you can have more than 1 value of x that actually work. And you can check it. If you put 2 into this guy, 2 minus 2 is 0. It doesn't even matter what's over here. 0 times anything is 0, so it works. If you put in for negative 3 plus 3, this is going to go to 0, which is what I told you it had to be. And so it doesn't even matter what's over here. It's going to be multiplied by 0, so it satisfies the equation. The reason I'm showing you this now is because I'm building up some skills. In just a minute, I'll show you how to solve an equation that requires factoring that you really don't have any other way to solve other than to factor it first and then set each part equal to 0. So anytime you see 2 terms in parentheses equal to 0, you can set either one equal to 0, and you're going to get 2 answers. So, much like this guy, what if you have 2x minus 5 times 3x plus 6, and you set the whole enchilada equal to 0? This is an equation. I ask you solve for x. Well, you immediately recognize that I have 2 binomials multiplied by each other. Either one could be equal to 0, and that would drive the whole thing to 0, and it would work. So you just set them equal to 0. 2x minus 5 could be equal to 0. Also, 3x plus 6 could be equal to 0, and that would work too. So when we go and solve it, we'll add 5 to both sides. So we'll have 2x is equal to 5. And here, to find x, we'll just divide both sides by 2. And we've been doing this enough to know that for that guy, x will be 5/2. And then over here, we'll subtract 6 from both sides. So it disappears here, get -6 on the other side. Divide by 3, so that x is equal to -2. When we do this division, we get -2. So again, we get two values that both work. If I take this and I plug it in, what I'm going to get is 3 times -2 is -6 plus 6. This goes to 0. It drives the whole thing to 0, and it works. If I take this and plug it in, it's going to drive the whole thing to 0, and it's also going to work. So remember, anytime you have an equation set equal to 0 and you have two things multiplied together, you can set either one equal to 0. And I've given you the reason why. So you're going to have two solutions for some equations. All right, only a couple more problems. But now you're going to see why we just did that. X squared minus 7x is equal to 0. Now, I asked you solve this equation. Now, before we started talking about this stuff, you wouldn't know how to do it because you have an x squared and you have a -7x. You can't combine terms. You can't easily isolate x. There's no way to put x all by itself in one corner on the other side of the equal sign. You can't do it. But what you do notice right away, since we were talking about it, this section, is that there's an x common here and there's an x wrapped up inside here that's common. So I can factor out an x. And that's all I can factor out, but it's enough. So I'll pull this out, and what I'll have inside is x minus 7. And you can check it because x times x is x squared, x times -7 is -7x. It's still equal to 0. Now, if you kind of think about it, and if you wrap a parentheses around this, then you have two things multiplied together in parentheses and they're set equal to 0. So because of what we said a minute ago, you can set each one of them equal to 0. And the first one's easy. X can be equal to 0. The second one is x minus 7 is equal to 0. If you solve this, you just add 7 to both sides, so x is equal to 7. So we have two answers. X is equal to 0, x is equal to 7. And if you want to check your work, take the 0, stick it in here. 0 squared is 0, minus 7 times 0, which is 0. So you get 0. So it checks. Put 7 in here. 7 times 7 is 49, minus 7 times 7 is 49. So you get 0 for each case. So it's just one of those things where I had to show you what to do when you have those two parentheses there and how to solve it before you could apply it to this. You factor it out and then you recognize that you can set each one of these guys equal to 0. And the same thing is going to hold true for our very last problem of this section. What if we have 8x squared minus 16x, and that's equal to 0? If I ask you to solve this equation, you're not going to know how to do it initially because you can't isolate x, you can't add them, you can't get it all together. But then you realize, I can factor. I have an 8 here and I have a 16 here. So I know that there's an 8 wrapped in here, so I can factor out an 8. And there's an x squared and an x, so I know I have at least one x that's common. So I open my parentheses. The only thing that makes sense in here is x for this term to multiply to give me this, minus sign because of this, and then a 2. This is the only thing that works. 8x times x gives me this. 8x times -2 gives me -16x. Now, once I have it in this form, I have, like I said, two things multiplied together equal to 0, so I can set each one. 8x is equal to 0. X minus 2 is equal to 0, and they're each going to lead to a different solution. Here, x is going to be 0 divided by 8, because I divide 8 by both sides, so x is going to be equal to 0. And over here, I just add 2 to both sides, so x is equal to 2. Add 2 to the left, it disappears. Add 2 to the right, and there you go. So again, I get two answers. One of them 0, one of them's 2. If you want to check your work, stick a 0 in here. 8 times 0 gives you 0. 16 times 0 gives you 0, so it satisfies that it's equal to 0. If you take 2 and put it in here, 2 squared is 4. 8 times 4 is 32. But if you put 2 over here, 16 times 2 is also 32. So you have 32 minus 32, which gives you 0. So you get both solutions. So we've done a tremendous amount in this section. We talked about what is factoring, what are factors, why is factoring important. It's a way to simplify an expression. It's also a way to solve an equation. If you have an equation that you can easily see that you can't isolate x, but you can factor it, then go ahead and do that. And if it's set equal to 0, then you can set each individual component equal to 0, and you kind of end up with two mini equations there. So this section is kind of a lot of stuff. You're learning about factoring, you're learning about what factors are, but you're also learning how to apply it to solving equations. And so I hope that with these sequence of problems, you understand this. So make sure you can do all of this material. Practice extra problems and follow me on to the next section where we're going to continue learning how to factor and just getting more practice with different techniques of factoring. Learn anything at mathandscience.com.